Okay, so this process of the sperm maturing, this whole process takes about 70 days for a type B to mature. And a young man is producing 300,000 sperm per minute or 400 million per day. So we're really just looking at one tiny little spot, and this is happening all throughout the seminiferous tubules constantly. And then this kind of shows a close-up of as the sperm matures. Sorry, that word was escaping me. Kind of how it goes from the cell at the end of meiosis and kind of grows the flagella and becomes a little bit more sperm-like, if you want, and kind of the features of the sperm. So it has two parts, the head and the tail. The head is pear-shaped. It has a nucleus and an acrosome. The nucleus has the haploid set of chromosomes. Of course, that's the most important part. And then this acrosome is a lysosome that has enzymes in it. This kind of covering half of the nucleus, and then that contains the enzymes that are needed to penetrate the egg, if that happens. And then the basal body is at the end where the flagellum attaches, and then of course the flagella tail. The tail is divided into three regions. The midpiece has a lot of mitochondria. They produce ATP for the movement of the flagella. The principal piece is surrounded by a sheath of supporting fibers that makes up most of the tail, and then the end piece is the very narrow tip of the flagella. And so there's kind of a picture of what that looks like, and then a real micrograph of what that is. The sperm are going to join together with semen, the seminal fluid. That's the fluid that's expelled. 2 to 5 milliliters can be expelled during ejaculation. So 60% is the seminal vesicle fluid, 30% prostatic fluid, 10% sperm, and the spermatic duct secretions. A normal sperm count would be 50 to 120 million sperm per milliliter, and then lower than 20 to 25 million could be considered infertility. The stickiness of semen promotes fertilization. So there's clotting enzymes that kind of converts to this sticky fibrin-like protein to help entangle the sperm, and it sticks to the inner wall of the vagina and the cervix. And that makes sure that the semen doesn't drain back into the vagina and it sticks where it's landed, I guess. This helps the uptake of sperm into the uterus. And so 20 to 30 minutes after ejaculation, we would expect enzymes to break down and liquefies the semen. The sperm become active, and then they are able to kind of be moved into the uterus and the uterine tubes. And we are going to pick up that when we get into the female side. Sperm motility is based on two requirements: an elevated pH and an energy source. So needs a higher pH. And then the seminal vesicles are what provide fructose and other sugars for the mitochondria for that movement of the flagella.